You're listening to the Skeptic's Guide to the Universe, your escape to reality.
Hello and welcome to the Skeptic's Guide to the Universe. Today is Thursday, January 26, 2023, and this is your host, Stephen Novella. Joining me this week are Bob Novella.
Hey, everybody.
Kara Santamaria.
Howdy.
Jay Novella.
Hey, guys.
And Evan Bernstein.
Good evening, folks.
So, have you guys heard the news about what Pope Francis said about the LGBTQ community?
No. What did he say? I did not.
I mean, it's pretty interesting, and I think it shows how far we've come in a way. But basically, Pope Francis, who, by the way, now has a personal advisor who is openly gay, who 10 years ago considered each other mortal enemies, by his own words, not Pope Francis, but the other guy. But this is Juan Carlos Cruz. Pope Francis gave a major speech where he basically said a couple of things. One is that we have to distinguish something that is a sin from something that should be a crime. And he said, there's nothing about homosexuality that means it should be a crime. It's still the position of the Catholic Church that homosexuality is, they use a specific word, but it basically means unnatural, and it goes against the will of God. But that two things: it's not a crime, which is important because the Catholic Church has supported criminalizing homosexuality in the past. There are still some Catholic bishops in certain countries around the world that do that, but it's now the official position of the Catholic Church to oppose laws which criminalize homosexuality.
Amazing.
Or the LGBTQ in any way. And he said, while homosexuality may go against God, it goes even more against God. It's even more of a sin, basically, to not respect somebody's dignity. And that basically, the Catholic Church needs to be open to the LGBTQ community, right? So basically, they should be respected. They should be welcomed. They shouldn't be criminalized. It's still a sin, but, we're not going to make a big deal about it, basically, which is really a change for the Catholic Church. I mean, think about that.
Yeah. Steve, ever since, the whole child, child abuse epidemic that they had going on, it was institutionalized child abuse on a level that is doubt has been rivaled by any other organization. To hear them try to have any kind of moral high ground or play it off like they're the good guys, to me, is laughable.
Well, it's true, but
it's just a movement towards progress. I don't think it's about going, look at us, we're so high and mighty, is it?
I mean, there might be an element of trying to buff up the brand a little bit. I mean, they're not doing well in a lot of communities.
But this pope is a more progressive pope.
Absolutely. I think he's legitimately more progressive. I think he really means what he says. And it is progress. It's not the progress that I think, a progressive person would think is far enough.
No, it's definitely not.
But it's a remarkable change.
Yeah, but even still, one very minor good deed, it's like, let's just forget about all that crazy stuff that happened.
I don't think there's change, and therefore, forget all the child abuse scandal.
No, but the fact is that they haven't even addressed the child abuse thing adequately. That's the real problem.
That's true.
That is true.
So we have, that kind of lingering. It's like, okay, well, great move. You've taken basically a half a step in the right direction. But how about owning up to and trying to make amends in some way, to the incredible crimes that you committed? That's why I look at this and I'm like, yeah, okay, I think you're right. I think this is a branding thing, if anything.
Yeah, I mean, I'm not that cynical. I do think it's a legitimate move. Again, it's hard to know what the motives are, and I wouldn't just assume the most cynical position. But it is fair to say, that's great. Now, what about all the buggery? Let's talk about that. But also, responding positively when somebody or an institution or whatever does something positive, even if it's a halfway step, and even if it's not in other things we'd like to see, is good positive reinforcement. I think we should, you give the devil his due, right? This was a move in the right direction. We should acknowledge it as such and accept it as such and go from there. That doesn't mean we give him a pass or we forget the other things that are highly problematic.
Yeah, it certainly doesn't absolve them. And if the Pope says it, I don't understand really how the law of Catholicism works as far as the Pope goes. I mean, Francis won't be there forever, and what's to stop the next Pope from coming in and basically just reversing that statement and saying the Church's position is something different now, and that's the way that is.
Yeah, I mean, basically,
the problem
establishes what the Church's position is.
The thing about the Pope is supposed to be the mouthpiece of God. So when the Pope says something like this, from a religious point of view, it's supposed to be what God wants.
Mm-hmm.
You know what I mean? So I think they're very careful about kind of undoing stuff that other popes have done because, that's ultimately, pretty ridiculous.
Mm-hmm.
He has, and there's a council of some sort is it cardinals or I'm not sure. What does the Pope have to basically get, need the support of whatever kind of councils there are to help back him up on these kinds of proclamations, if that's what it is.
Maybe politically, but I don't think legally. I think the Pope's word is the word of the Catholic Church, basically.
Wow, that's powerful.
Yeah. Oh, okay. Yeah. Very powerful.
That's powerful.
Indeed.
Yeah. But again, internal politics, who knows? I'm not an expert on the Catholic Church, but
no, it's a black box to me.
It is to the world, Ev. They don't. The inner workings of what goes on at the Vatican is, it's largely a mystery. We
don't get the minutes of the meeting. We can't read them.
No. It is, from what I've read about it, it's like living in a different universe. Like the normal rules of our society, that's not the way that those people are living. It's like a completely different.
It's an extremely authoritarian culture. Extremely.
Yeah.
And that permeates through all of their institutions. I mean, even just like Catholic schools in the United States have that authoritarian vibe that sets them apart from other similar institutions,
Well, look, if change does have to start somewhere. So, better late than never, I suppose.
Well, it's better that I'm not saying it or doubling down on, this is, supporting the criminalization of it. And I do like the justification, because basically what I like about it is, churches should not get involved in the law, right? There should be a clean break from that. And saying that, whatever we believe religiously about what God thinks about this shouldn't make it illegal. And I also like the emphasis on respecting people's dignity and applying charity and tenderness, to quote a word that he used, and to be accepting to and welcoming to everybody over, we're going to, strictly impose our moral ethos, that's also a good shift, just big picture wise, I think the religions of the world need to move in this direction. Fine, have your faith, believe what you want, but don't set laws for other people or support basically laws that really are immoral, and take, dignity away from other people, to enforce your own belief system and emphasize being good to people. I mean, who said that originally? Some Jesus guy, right? I mean, seriously, it always amazes me how, the Novella boys were all raised Catholic, and I took 4 years of theology. I've read the Bible, and we studied it. The cornerstone of Christianity is supposed to be to love thy neighbor and all that stuff, and yet it's amazing how unchristian so many institutions of Christianity are. Based upon their moralizing, really shameful approach that they take. It's just amazing. And the Pope saying, let's bring it back to being nice to people and put that center is a positive move.
Yeah, that's not exactly what happened here, but I mean, I see what you're saying.
No, I think at least that's the philosophy. That is the logic, the justification that he's using. It's more important to show kindness and tenderness to people than to condemn them for one thing they're doing that we don't agree with. We still should welcome them into the community and be nice to them, and we shouldn't criminalize their very existence. That's a good thing.
Yeah, sure.
Even as a show, it still has an effect, I think, on the conversation. Christianity, the Catholic Church, I believe, is still the biggest religion in the world.
More than Raelians, huh?
Oh, Christ.
Well, it's definitely Christianity. Christianity is 31%, but I think within Christianity, the Catholic Church is the biggest.
Catholicism.
Yeah, Catholicism. All right, let's move on. Kara,
That's me.
You're gonna start us off with a what's the word?
Yeah, it's a fun one. God, I say that every time. How boring am I?
It's all right. Embrace it.
This is
I know. I'm just going to embrace it. I have to listen to it again because the way I want to say this word is always wrong. So I'm going to listen to what they say.
It's aposematism.
It's not, though.
It is. I just listened to it. It's aposematism.
Are you a positive?
I'm hearing in multiple places aposematism.
But that's how you might want to say it, but it sounds wrong.
No, the way I want to say it is
That's not even a word.
aposematism. But everything I'm seeing is aposematism, and now you're saying it's aposematism?
That's what I'm hearing.
I've had a couple different sites where I hit the little thingy, and it's aposematic, but aposematism.
Yeah, why, if it was aposematic, why wouldn't it be aposematism?
I mean, aposematic makes sense, but
aposematism is how the Brits say it.
I think we should now, I'm convinced, now I think we should have a new segment, brand new segment of the show, just on how do you pronounce this damn word. That's it. Just how to pronounce it. I like it.
Okay, so however you want to pronounce this word, I'm going to spell it so you know what we're talking about. aposematism. Aposematism.
Aposematism.
Aposematism.
it's a weird one. It's a
weird word.
Yeah.
Let's break it down. So it was first coined, I have that here, by British evolutionary biologist Edward Bagnall Poulton, which means that it was probably first pronounced aposematism, which is how the Audio UK pronunciation is on an etymology website. I say. So it comes from Greek roots, apo meaning away from, away.
Like a pose.
And somatic, which means... Anyone? I had no idea.
Well, I know what semantic.
Somatic is dealing with the body.
But not with an O, with an E.
Oh.
S-E-M-A. I know. I was like, it sounds so much. Yeah. Somatic is with an O, and semantic, right, is with language. But somatic, which I had no idea, is danger sign.
Danger.
It's a sign of danger. So this makes sense because aposematism is when an animal advertises, especially through its coloring, that it is a dangerous animal to attack or to eat.
Oh, like one of those lime green frogs. You don't want to eat it because
exactly.
you get poisoned.
When you see really like the poison dart frog, ladybugs, some butterflies, you see this quite often. Many wasps that are black and yellow.
Caterpillars.
So that's the most common aposematism. That's the possession of bright contrasting colors. But there are other types of warning systems. You know, sometimes there are like auditory warning systems, like like a rattlesnake.
Yep.
And there are other forms.
The cobra's wings, or whatever you call them.
Right. Yeah, the big flares. And so the reason that these things, evolved, right? Because, well, if it's dangerous and toxic, why would it need to evolve a warning? Because they still don't want to get bitten, or eaten. And so it actually protects the species. Like they evolved these protective mechanisms to kind of say, I am noxious, I am dangerous. F around and find out. but this is a visual or conspicuous cue that will help you understand that. And so, yes, you will sometimes see, there are other forms of the word, like we've been saying aposematism, but you'll see aposematic. An aposematic mechanism is a common way that you'll see it written. Yeah, it just means that it has these capabilities for defense, or that it's, somehow toxic or noxious or not a good idea to predate upon. Mm-hmm. I love it. So yeah, aposematic or aposematism.
Now, that phenomenon will always remind me of the Prometheus movie when the biologist encounters an alien creature clearly displaying aposematism. Mm-hmm. Like, warning, I'm dangerous. And of course he gets in its grill and gets killed.
Yeah, he goes up to it and goes coochie coo or something. It is like, it was painful to watch.
So
more painful than whatever became of that character. It was more painful to watch.
It may very well be the worst writing in that entire
I know it's such a bad movie.
Gosh, it is bad.
Let's not go there
I
again.
want to have a sit down with the science advisor, if any, for that damn movie.
Well, but also to be fair, just in case if like there was a really legitimate science advisor, they don't have to use what they say.
That's right. They don't have to take
There
the
probably
advice.
was somebody who was like, "Please don't do this," and they were like, "Oh well."
I think they accidentally had a Scientology advisor.
Right.
That's what happened.
Xenu would have done this. And
Actually, now that you think about it, that's actually quite plausible. All right,
oh, gosh.
Bob, tell us about NASA experimental technology. How could this be not interesting?
Right? Yeah, I mean, I've done this, I think, a few times now, and that's kind of an annual thing, I think. So NASA has released its annual funding for NIAC, the NASA Innovative Advanced Concepts Program, and the list is sweet. Now that I'm thinking about it, is it pronounced NIAC or NIAC or NIAC?
Nias.
I don't know. But
It's aposematism.
NIAC is essentially, it's funding for early stage studies that could possibly maybe be part of some future missions. It consists of $175,000 grants for 14 forward thinkers and their pet projects. If any of them make it to subsequent phases, then the money goes up. And of course, also with the odds of them going up as well, that they'll actually make their ideas a reality. So if you look, I looked at the promotional video for NIAC, and it says stuff like high risk, high reward, making the impossible possible, boldly transforming the future, and NASA's most forward-thinking technology development program. All right, let's see how accurate these marketing slogans are. The first one I'm going to cover is called FLUTE, and that stands for Fluidic Telescope. And if you've got a good memory, I actually talked about this earlier in 2022, I think around April 2022. So we're nearing the limit of conventional space-based telescopes in UV, optical, and IR range. Now, if we want to detect things like Earth-like exoplanets and even evidence of extraterrestrial life on them using space telescopes, bigger is better by definition. We go bigger and we're going to get better and better. Now, James Webb has a 6.5 meter aperture, and that's big. And you might think, we'll get to 10 next time. I don't think so. 10 meters is just going to be way too expensive. It's not in any NASA or any other space program's budget in the foreseeable future. We're getting to the point where it's just like we need a paradigm change. So we have to get creative, and that's what Edward Balaban of NASA Ames Research Center did with his proposal. Get this, for a whopping 50-meter unsegmented primary mirror. 50 meters. And how can this possibly be done? It's based on fluidic shaping in microgravity. And now we know that surface tension can make perfect spheres of water, right? If you get a tiny enough drop of water where the surface tension is essentially stronger than gravity, I think it's a couple of millimeters, you can get essentially a perfect sphere of water. And something so perfectly shaped would make a wonderful, an amazing optical device. So the microgravity of space then can be used to take advantage of surface tension and make these wonderfully precise optical components, accurate down to like sub-nanometer, really, really accurate. And also critically important, in addition, this technique is scale invariant, meaning that we can make a lens-like surface in space up to hundreds of meters in diameter. Hundreds of meters. Incredible. With that could allow us to image exoplanets directly and probably see the shapes of the continents, perhaps, or even weather. Who knows? It's hard to imagine, what a space telescope that's 200 or 300 meters in diameter, what we could really see with that. We could observe star and galaxy formation. We could find more about dark matter, maybe even figure out what it is. The list goes on and on. So that one was really cool. Fluidic telescope. I would love to see that. And they've done tests. They've actually done tests as much as they could on the Earth and in labs and in free fall and things like that. And they've shown that this stuff works. So it's just a matter of doing these other tests and more research, and I think we could do it. It'd be great. All right, the next one is called Titan Air, and it's a seaplane from Planet Enterprise's Quinn Morley. But this is a seaplane like you've never heard of. All right, so where can we fly in our solar system? Now, when I say fly, I mean aerodynamic flight in a native atmosphere. Earth, of course, right? There's also Mars. There's a wispy atmosphere. Venus.
Yeah, a little helicopter working.
Venus, of course, is a thick enough atmosphere. The outer gas planets, and also one more, Titan, a moon of Saturn, Titan. I think it's the second biggest moon in the solar system.
That's no moon.
Huh? That's no moon. Now, Titan is the best in a lot of ways because it's got 4 times the density of Earth's atmosphere. So it's a crazy dense atmosphere, and it's got 1/7 of the gravity. I mean, those two things alone make it aerodynamically an amazing place to be. Planet scientist Ralph Lorenz at Johns Hopkins calls Titan an aviator's paradise. So now, ultimately, the fact, though, that it rains methane and water ice is granite hard is irrelevant when it comes to this kind of thing in terms of the aerodynamics and what you can do. So any flight there will cost peanuts energy wise. Now, not counting, of course, the expense of rocketing there and all the R&D. And well, you get the idea. But once you're there, it's very cheap because you could do fly float. You're kind of like, it's so dense that it really doesn't take much energy at all. His idea here is to create something called Aviator, AVIATR, and that stands for Aerial Vehicle for In Situ and Airborne Titan Reconnaissance. I bet they had multiple meetings to put together that acronym. Incredible. All right, so I'll let Quinn Morley explain the rest. This is what he wants to do. He said, this Titan Flyer concept aims to drink in methane condensation and organic material through a permeable section of the leading edge wing skin. You got that? So capillary features on the inside of the wing will collect this ingested material and combine it into a continuous fluid stream, which can then be routed to science instruments inside the flyer. So it's going to suck in the ambient atmosphere and do experiments on it. He continues, to enable intermittent low-altitude flight, the flyer will land on the seas of Titan like a flying boat, except boat implies water, and on Titan, the lakes are made of methane. We're calling it a flying laker. Okay, that's goofy. That's a real goofy name. But imagine seeing this thing, this ship, and the artist's imagery was like this big, thick, kind of stubby plane with these big wings. And so imagine that floating on a methane lake and then slowly flying off into the Titan sky. It would be an amazing science image, like nothing we've ever seen. So that would be very, very cool and very, very bizarre and creative. All right, I'll do one more. There's a bunch of these. These were the most interesting to me. This last one was my favorite of the batch this year, and it is called pellet beam propulsion. This is from Artur Devoyan, University of California. This was inspired by laser solar sails. So if you want to learn more about them, read our book, Skeptics Guide to the Future. So using a laser and a sail to move a spacecraft has a big future. And I believe that technique, though, has a big issue that needs to be addressed. What's the biggest issue really for using a laser to propel a sail
the
through
sail
space?
itself is going to get ripped
size
apart.
of the sail.
Yeah, those are hard, but the biggest inherent problem though is the divergence of the laser beam. It's coherent light, but eventually it's going to diverge and eventually get uselessly attenuated, right? So if you want to move anything fast using that technique, you need, and if it has a decent amount of mass, right? You want to move something that's got some mass to it. You're going to need really, really powerful lasers, at least a gigawatt or terawatt class lasers, which are very expensive. Even better would be yottawatt, right, Evan? But they don't exist yet.
Always.
That's not on the table now.
Yotta doesn't
We won't
exist
have
yet,
that for a
Dan.
while. But you can do it with smaller lasers. You can use this technique with smaller lasers, but only if your cargo is very low mass. Right. So, and we've talked about that. They've got plans for these nano, cargoes weighing a gram that they could laser. They can use lasers to push them to Proxima Centauri in crazy amount of time, up to 20% the speed of light, I think, and getting there in 20 years. Amazing. So to overcome those issues, at least over the short term anyway, is where this pellet beam propulsion comes in. So it's a similar idea, but it's got an interesting twist to it. And so it's not a beam of pure laser light. what the lasers would do is they would ablate these tiny particles from a material, right? So you focus the laser on a material, and you've got these tiny particles are going to come flying off. And apparently they can take those particles and use the laser to send them in a specific direction. The particles are going at approximately 119 kilometers per second, or 74 miles per second. So you've got these microscopic but super, super fast particles flying away down this laser beam, essentially. And such a beam doesn't diverge nearly as much and as fast as a laser beam. And since the particles already have mass, right? Photons have no mass. They do have an inherent momentum, but they don't have mass. These particles do have mass, and because of that, the amount of momentum that they can transfer to whatever they hit is very, very high. And the plan is that these particles would hit the back of the ship, kind of like a pusher plate of sorts. I tried to find out details about what is the back of the ship going to look like. It's being hit all by probably millions of particles traveling 74 miles a second. So how much mass of your ship is going to be this material that's going to absorb that? It's going to take all those hits to push the ship, but also it's got to protect the cargo, right? So I found no details, and I wonder if is that a weakness of this method? I don't know. But if this works, it's going to be very interesting. So imagine this. We all know Voyager 1, right? Voyager 1 took 35 years to get to the outer system's heliopause.
Yeah.
And that's at 123 AU, which is 123 times the distance of the Earth, essentially, from the sun. So using this technique with a spaceship that weighs a ton, it could get that same distance in about 4 years. So instead of 35 years, it could do it in about 4 years. But I did some calculations. So if you have a 10 megawatt laser, and these pebbles could accelerate a 1-ton ship to 353,648 miles per hour. That's 5,700 kilometers per hour, or about 100 miles per second. 1 ton traveling 100 miles per second. Wow, that would make a hell of a kinetic weapon. Wow. So that's fast. Now, you're not going to be flying to Proxima Centauri at that velocity. It's still going to take you way, way too long. But you can tool around the solar system, or even go to the edge of the solar system. Like, say, if you want to use the sun as a solar gravitational lens. I talked about that on the show. Oh, God, what was that, a few years ago? But to do that, to use the sun as a solar gravitational lens to be the most amazing lens we've ever considered, you'd have to go to 500 AU. And that would take quite a crazy amount of time. But using this technique, you can get there in maybe 20 years, which is crazy fast. That's what makes this pellet beam propulsion really interesting. It's like, it's kind of intermediary. It's not something that we could ever use to go to Proxima Centauri, but for getting around the solar system, it's really interesting. And I want to find some calculations where they talk about, what if we use a really powerful laser? What would that do? So imagine you use an exawatt or zettawatt class lasers. So that's going to kick off and ablate all those particles, and they're probably going to be going much faster than 74 miles per second, right? Can you use that as your pellet beam propulsion? I don't know. I suspect that the particles would be going too fast, and any kind of pusher plate or anything that you use at the back of your ship wouldn't be enough. But maybe it would. Maybe we can use this to go, so fast that we could conceivably use it as a sort of propulsion for Proxima Centauri, the closest star. I don't know. It's interesting to think about. And so that's it. So that's NIAC for this year. Go online, search for NASA and NIAC, NIAC, and you'll see all the other contenders. And it was all very, very interesting. Thank you. I'm done.
Pretty cool.
Yep.
I'd like to see any research into the solar sail technology or the light sail technology.
Yeah, that's got some major crazy potential for the next 100, 200 years.
But there's still definitely some technological hurdles that need to be overcome.
Yeah.
All right, Jay.
Yo.
Do you want to do your segment now, or you want to wait till later in the show?
Well, I mean, I do have Who's That Noisy, so you usually want to space it out.
Sure you want to get it out of the way?
Sounds like...
I get it.
I get it.
I got you. You know what's funny, Steve?
Yeah.
what Steve just said.
That I'm gonna say the word procrastination or some form of the word procrastinate, probably more than any word I've ever said in any news item before,
Okay.
other than words like the.
Okay.
Doesn't
Or
that impress you?
slappy.
In case you're interested, scientists who've been analyzing procrastination have determined that approximately 20% of adults are chronic procrastinators. And I know a few people that fit this category pretty well. So in this context, procrastination means delaying a task that should be done now, right?
Are you talking about me?
I don't know. I could be, Bob. I'm talking about myself as well. Even when the procrastinator knows they're in some way damaging themselves, they still do it. They still decide to put that task off. Fred Johansson, who is a clinical psychologist at Sofia Hemmet University in Stockholm, published his and his team's results in JAMA Network Open. That's a journal. And he and his team studied thousands of university students. The scientists determined that procrastination can create some bad outcomes. So here's the list: depression, anxiety, stress, disabling arm pain, poor sleep quality, physical inactivity, loneliness, and economic difficulties.
Wait, disabling arm pain? What's
Yeah,
that?
they were surprised about that. I've never really even heard of that before, like with these other symptoms or ailments. So I found that really interesting. This study is one of the largest to date that's able to link procrastination to actual health effects. And this study has found similar results that several other studies have found, meaning that there are physical health consequences to procrastination, one way or the other. So the researchers were not sure if procrastination was the source of all these outcomes or if those outcomes bring on procrastination, or it could even be both, can go both ways. It's difficult. It's a very difficult thing to study. So in this particular study, 3,500 students were tracked over 9 months, and this allowed the researchers to determine if, health issues came after students procrastinated, right? So averaging out the results, procrastinating students were more likely to develop one or more of the issues that I listed versus those students who didn't procrastinate. You understand now how often I'm using the word procrastinate here?
Yep.
Yeah.
Just say the
Procrastinators
the P
were
word.
at a greater risk of developing physical and physiological issues even at a later point down the road after they procrastinated. I used it twice in one sentence right there.
Mm-hmm.
It's important to note that this was an observational study, right? This wasn't like, testing somebody's blood. This was literally them just watching the behavior of their test subjects. So these kinds of studies can find patterns that point to a conclusion but don't have physical evidence of their conclusion. And this is why the study results are compared to other similar studies, because if they all conclude similar outcomes, it adds more credence to all of the studies, right? So the body of work gets bigger, and they're all kind of showing similar outcomes, meaning, we don't have any physical evidence other than what we've observed. But when you keep running studies and they're showing similar outcomes, it does say, it does give value to all the other studies. Previous studies have found that procrastinating at bedtime can cause depression, and another study found procrastination was linked to poor heart health, right? So you have a collection of studies here now that are showing that there is a connection between procrastination and physical and mental health. Researchers think that stress caused by procrastination can build up over time and contribute to unhealthy outcomes, which I think makes a lot of sense here, right? Because there is a stress factor that procrastination brings with it. When you procrastinate, it can actually stress you out because you're not doing the things that you know what you should be doing, and you're not doing them. And stress is very bad, right? Stress can cause a lot of the symptoms that are in this list, if not all of them. So putting off a task here and there, this is not what we're talking about. That's not really procrastination. Those are moments of rare procrastination in say person A, but person B, who procrastinates as part of a behavioral lifestyle, that behavior permeates all of their activities in life that are affected by negative outcomes. So you got to look at it like it isn't like the infrequent procrastination, which is normal. People of all kinds will procrastinate on one level or another, but it's the people that are living inside of procrastination on top of procrastination that these results are talking about. So some procrastinators say they perform better under pressure, but researchers found that this is not the case, right? I've heard a ton of people say that in my life. I work really well. Like I'll get it done, in a way that I won't be able to do it unless I feel the pressure. I always thought that was BS, and it turns out that the scientists agree. In fact, procrastinators performed worse under pressure, making more mistakes and working slower than non-procrastinators. So that line of reasoning just is not sound. When working with loose deadlines, as an example, procrastinators tended to not complete their work or do it at all. So if you want to test if you're a procrastinator, think about how you would perform when you don't have a solid deadline in front of you. Like, I can finish it anytime over the next month or 2 months, right? When are you going to do it? Are you going to start working on it now?
Don't become a tax accountant if that's the case.
Yeah, right?
Sure.
Absolutely. You can't, procrastinating and being an accountant do not work at all. Some researchers believe that procrastinators could have trouble regulating their emotions, and they can be impulsive, and they can also be worriers. All these things kind of seem to go together. Procrastinators, however, are not actually lazy, though. This is a big thing. I think the common collective thinks if you're a procrastinator, you're just lazy. You don't want to do anything, and that's not actually what they observed. They found that procrastinators were busy doing other things, just not the things that caused them stress, or the things that were timely or important.
Yeah, like Fallout and Call of Duty.
Yeah, hell yeah. You just do something else with your time. You're not just lying in your bed looking at the ceiling. Like, procrastinators want to do things. They just don't want to do the things that are going to cause them stress. And most researchers believe that procrastination is a behavioral pattern that ultimately can be changed. So you can make yourself a worse procrastinator by procrastinating and simply not doing anything about your procrastination. So you gotta be on top of it and try to make changes. So how do you make changes? Well, the researchers had some perspectives on this. So the interesting thing about procrastination is that it's actually a way to avoid stress and negative emotions that a certain task will bring, right? So think about it situationally. Person doesn't want to do something, right? Doesn't want to do their homework, doesn't want to write that term paper, doesn't want to work on that thing, that big project that they have going on at work. So they're avoiding doing something that will bring them some level of pain, emotional pain or stress. So procrastination is a way to get immediate relief, but in the long term, what they found is it increases the aggregate amount of stress that you get. So one thing to keep in mind when you're procrastinating and you try to put it in the front of your head, I am procrastinating right now, right? You just say it. I'm procrastinating. I don't want to do this thing. You got to call yourself out on the BS that you're doing to yourself. You're not going to do a good job later. You're going to do a worse job if you do the work later. You should do it right away. And if you find yourself pushing it off, you have to tell yourself, I am literally right now just causing myself even more stress if I put it off and then have to deal with, feeling bad about myself and the negative mental effects that putting it off will have on you. Because that's part of the problem here is that people who procrastinate can get themselves into emotional tailspins where they feel bad about, the fact that they're procrastinating. They feel bad about missing a deadline or putting even more pressure on themselves when that you have to do the work now moment. You have 2 more days to write that paper or you're screwed. Now you're in an even more stressful environment. So a way to handle for a procrastinator to deal with their overall stress is to realize and emotionally accept the idea that procrastinating makes it worse. You got to forgive yourself for the past. Okay, I've been a bad procrastinator. I know I have this tendency, but you got to hit it head on and really think about your behavior in the moment when you're going to make that decision to not do the work. So it's no big surprise here, but one of the most effective ways to deal with procrastination is what, Kara? It's cognitive behavioral therapy.
Look at that.
Can you imagine?
I can.
We've discussed cognitive behavioral therapy many times on the show. We talk about it all the time. It's really one of, if not the best ways when you go to a therapist, if they're using cognitive behavioral therapy in their treatment of you. What we are finding over the last, how many years has it been around now, Kara? 30 plus years?
It's back, really. So it's probably even older than that, the earliest stages.
It has been proven to be very effective. Cognitive behavioral therapy works cognitive behavioral therapy works on an individual's behaviors. It helps you acknowledge what those behaviors are, and it helps you deal with your behaviors. And the good news is, like I said before, behaviors can be changed. Behaviors can in a lot of ways be learned and reinforced and made stronger, negative and positive behaviors. So you can reverse a negative behavior and learn some positive behaviors on top of it. Procrastinators often find themselves in a loop of shame. I was trying to explain this before. They feel stressed about starting a task, so they put it off. Then they feel ashamed for putting it off, which in the end makes them feel worse than they did if they just did the initial task and worked on it as they should be working on it. But again, these are behaviors, and you can fix them.
Yeah, one of the things that causes people to procrastinate, there's multiple psychological reasons, but one is that the task seems overwhelming. And so if you break it down into smaller tasks and just do like the smallest piece you can, that sort of can get you over the hump and get started.
Yeah, and use something called, it's another CBT approach called behavioral activation.
Yeah.
It's all about like once you get moving, like once the ball starts rolling, it actually gets its own momentum and keeps rolling. But that first push is really hard. You know that with like working out, with almost anything. It's like just starting is the hardest part.
Just start. Yeah.
Yeah.
No, absolutely. All right. Thanks, Jay. Good, we got that out of the way. All right, guys, I'm going to give you an update on bacteria that eat plastic.
Yeah, we've been hearing about this for like 30 years now.
Yeah.
Yeah, but
well,
what do they poop?
They poop carbon dioxide, among other things. So we've been talking about the fact that plastic is a problem.
Oh, yeah.
So in a 2017 study found that only 9% of plastic is recycled. 12% is incinerated and 79% accumulated in landfills or the natural environment, like, the oceans. 380 million tons of plastic are produced every year, and this figure will increase by 70% by 2050.
It's on the rise, big time.
Yeah.
On the rise.
By
Crazy.
a significant amount unless we
My
make
God.
changes. So, we have to figure out, it's the thing is, there is some low-hanging fruit, most of the plastic that ends up in the oceans comes from a small number of rivers, being produced by a small number of countries. Unfortunately, some of those countries are receiving the world's plastic waste, although that's been changing recently. And they just don't, it's the countries that don't have a system in place to properly deal with the plastic, either incinerate it or put it into a landfill. So that's like an identifiable problem that can be fixed. But even if everybody was doing what they should do, which would be a vast improvement on what we have now, that's still a lot of plastic building up in the environment. And just continuing to use landfills may not be sustainable. So the idea of having bacteria eat the plastic is superficially very appealing, right? But of course, we have to do the deep dive on, does it make sense when you crunch the numbers? Does it make sense economically? What is the actual environmental impact? What are the risks, if any? There's been a couple of updates. One that is significant. Just to ask the question, for the bacteria that we know that break down plastic, are they actually eating it? Like, are they metabolizing it, or is it just breaking down in their presence? And so what they did was very clever. They made plastic with the carbon in the plastic, because most plastics are basically polymers of carbon. They made them with carbon-13. And then what they found was that this carbon dioxide, CO2, released when a blanket of bacteria covered the plastic and the plastic was breaking down, that C13 labeled carbon dioxide would then appear, it would bubble up through the water that the plastic and the bacteria was in. So it does seem like the bacteria are actually eating the plastic, right? They are metabolizing it. They are using it for energy.
Do they like it?
They like it.
Yeah, but Steve, wouldn't we know? Because, bottom line is, there's less plastic after the bacteria got to it, right?
Yeah, that's correct. Yeah, but you're right. And then it's reasonable to assume that they are eating it, but they wanted to prove it. And so just one little proof of concept study that's interesting. But they also found some other things. In their experiment, the bacteria that they used, Rhodococcus ruber, broke down about 1% of the plastic available to it per year. That's not a lot. That's pretty slow. But still, it's better than nothing. There was also an interesting survey of this from a couple of years ago of soil and ocean bacteria that found 30,000 different bacterial enzymes capable of breaking down pretty much every different kind of plastic.
How many?
30,000. 30,000 known
Damn.
bacterial enzymes that can break down plastic. Now, that's not a coincidence because bacteria eat plant fibers, and these are those enzymes, right? So these are enzymes that the bacteria evolved to break down certain plant fibers, and they happen to also break down certain kind of plastics. Not every enzyme breaks down every kind of plastic. You have to match the right enzyme with the right type. So that's fortuitous. Another study also found that in places where there's a lot of plastic in the environment, bacteria are essentially evolving to eat the plastic.
I love bacteria.
Yeah, so the bacteria with more and more of those enzymes are becoming more populous in the places where there's a lot of plastic, right? Which is that just happens whenever you put a huge potential food source somewhere. Things evolve to eat it, and those things thrive because they have a lot of food.
So maybe we should throw even more plastic at them so that they could evolve faster. Would that be a good strategy?
Well, yeah, it looks like we're doing that regardless.
Right. What does all this mean, though? That's fine. That's a good proof of concept. Sure, bacteria eat plastic. There's lots of potential genes out there. The advantage of bacteria, of course, is that they're self-reproducing. They make themselves, and they can make a lot of themselves very, very quickly. So they're useful machines as far as that's concerned. So how do we use it? So there's a couple of potential applications, none of which are happening on a large scale right now, because again, there's always that sort of scalability and economic issues that we need to get into. So one potential use is simply to add plastic-eating bacteria to places like landfills that are self-contained, but which have a lot of plastic. So you just basically put the bacteria in the landfill and let it eat the plastic. In some cases, this could reduce the volume, the mass of the plastic by 95%. So that gets rid of a lot of it. Breaks it down to like almost a powder. It's also the advantage. So one of the problems with recycling plastic is that a lot of plastic products are mixed plastic types. They're made of multiple different kinds of plastic, and those are hard to recycle because different plastics have different methods of recycling them. They're easier just to incinerate or just to put into a landfill. But these bacteria can selectively eat the plastic that they can eat, even if it's mixed in with other plastics. It just goes for the plastic it can eat, and it eats it. So that's a good thing. Another thing that we could do, and this is probably the most likely application, is to incorporate plastic-eating bacteria into a circular production method. So there are bacteria that don't just eat the plastic, they break it down into its constituent parts. And those parts could then be used to make new plastic. Now, this is different than existing recycling methods. Right now, you break down plastic to recycle it. That the broken down plastic gets used to make lower grade plastic, which can't be recycled, and that's the end of the recycling. For that plastic, we basically just get one more use out of it, right? And not even like the same product. It goes into like, we're going to make plastic for filler for concrete or things like that, like not like the plastic that it's recycled from in the first place. But this would be fully circular because you could use the raw material to make the same kind of plastic and then break it down again and make the same kind of plastic again. I mean, obviously, any process like that is going to have some waste, so you're going to have to feed some raw material into it, but that could go a long way to making plastic into a completely circular, or mostly circular production process rather than just adding plastic to the environment. To maximize the benefit of this, we may need to change which kinds of plastic we use for which applications to maximize the types of plastics that are most amenable to this process. But again, there's already proof of concept, demonstrations out there. This would just be something that would need to be scaled up. And, the big question that becomes the economics of it. So one of the problems is that making virgin plastic is really cheap. And it's cheaper than anything else that you do.
Yeah. Yeah. It's like, what is the incentive for these companies to do
Right. So unless there
this?
is an incentive, right, and of course that incentive could come in two big ways. The government could either fine them for not doing it or pay them for doing it, right? Carrots and sticks.
Or both.
Or both. Yeah, just this
Carrots and sticks.
The carrot stick approach. Although companies are really good at lobbying the government to go with the carrot and not the stick, which is what happened with the recent Inflation Reduction Act in the U.S. But still, it's working and it's better than nothing. But that's that's what often happens. But either way, if you make it economical to shift to a circular economy, that then takes care of the economic problem. That plastic is so damn cheap. Or you charge them for externalizing the cost of their product winding up polluting the environment,
Right, because it's not actually cheap if you put all that.
Right, if you include
equation.
the externalized cost, it's not cheap. It's fake cheap because you're just pretending like it's not your problem that your product is ending up in the environment.
But Steve, how legit is this? I mean, is the plastic that's out there in the oceans right now and out in the wild, is this the kind of plastic that this bacteria can eat?
Well, some of it. So since you bring that up, that's the third way to use it. Imagine if we just released a bioengineered bacteria into the world's oceans to eat plastic. That could have an effect, but I imagine there would be some squeamishness about releasing genetically engineered bacteria into the world's oceans. But I don't think it's impossible if we're really careful. Imagine if, with those 30,000 plastic-eating genes, imagine if we engineered a bacteria that can survive in salt water and has 20 or 30 of those genes that could take care of pretty much any kind of plastic. Also, a lot of kinds of plastic break down in UV light, so a lot of the plastic floating in the oceans breaks down, but it breaks down into smaller and smaller pieces, right? The microplastics.
Which is actually more dangerous.
It's actually more dangerous, but the bacteria have an easier time eating that. So
that's good.
Right? Because they basically more surface area, et cetera, they can eat it easier. You could imagine all of those things happening, developing some circular plastic chains, trying to reduce the volume and mass of plastic in landfills, trying to, reduce the amount of plastic in oceans. And then, of course, we have to stop putting it there in the first place by, putting pressure on countries that are not handling their plastic waste well to handling it well. And also, rich countries have to stop sending their plastic to poor countries who can't afford to take care of it properly.
What would you say
less of it.
is the fallacy at play when, let's say that there was extensive study done on this bacteria. It was found to be non-pathogenic. It was found to not be able to infect wildlife. It didn't really have any effect on the ocean's chemistry, but it successfully broke down plastics. Yet people were squeamish about it simply because you're releasing, it's like the known versus the unknown known.
Yeah.
You know what I mean? It's like the oceans are full of plastic. That's bad. But it's but that's already happening.
Yeah, I just call that an abuse of the precautionary principle, right? So they over-apply that. They go, we have to be careful. It's like, but not doing anything has consequences too.
Has worse consequences. Yeah, exactly.
It has known bad consequences. That's like...
This is like the COVID vaccine thing.
The COVID vaccine, or GMO foods. We know that we're going to have a problem without them, and you're putting that up against a theoretical problem that has never actually happened ever anywhere. So that's just the abuse of the precautionary principle.
It's so frustrating.
So but there's some opportunities here is the bottom line, but none of them exist yet. But there's interesting proofs of concept, and just the fact that there are 30,000 bacterial plastic-eating genes is kind of exciting. It means there's a lot of potential there. We should just CRISPR the hell out of some superbugs.
Yes, CRISPR the hell.
Start eating plastic.
So this is more all theoretical, Steve. They don't have a bacteria.
No, they do. They just, I said they were studying. These studies are all in actual bacteria that actually eat plastic or break it down.
They just haven't scaled it.
It's proof of concept research. They just haven't made a factory where they're doing it. That's the next part.
Bacteria factory.
Yeah,
there are a lot of bacteria factories, just not for this bacteria.
That's not new.
Yeah, that's not
like
uncommon.
your skin.
Well, and also producing things like bacteria or even yeasts are very common in large vats for industrial scale. That's really common.
Yeah,
it's really common.
Yeah, and we could make UV light on demand or just expose it to the sun, you know.
Ship
Exactly,
them around the
that's
world and
free.
ship them around the world in plastic containers. Oh, don't!
Well, everyone, we're going to take a quick break from our show to talk about our sponsor this week, Wondrium.
You know that we all love Wondrium, and I wanted to tell you guys about an awesome series that you can view. It's specific to Wondrium called Wondrium Insights, The Promises and Perils of Technology. It's actually hosted by my dear friend, Dr. Crystal Dilworth, and it's a 5-episode series where you can learn all about our relationship to technology, both good and bad, featuring awesome people like journalist David Kushner and astronaut Leland Melvin.
Kara,
Yeah?
Wondrium is our favorite educational platform because it has an incredible amount of documentaries, series, lessons, how-tos, and a ton more covering pretty much anything that you'd like to learn about. They've got a video about it.
Learn about what you love and love learning about it with Wondrium. Do what we did and sign up for Wondrium now. Right now, our listeners can get 2 years of Wondrium for the price of one. It's a fantastic deal. Sign up today with our special URL. Go to wondrium.com/skeptics. That's WONDRIUM.com/skeptics.
All right, guys, let's get back to the show. All right, Evan, tell us about rubble pile asteroids.
Yes, I'm going to do that, Steve. But first, we have an asteroid alert.
Oh, yeah?
No, seriously, we have an asteroid alert. It was discovered this past Saturday, heading towards Earth. And just mere minutes ago, did it nearly impact the Earth, Bob? Would you describe it as that?
No, it was super close. Never was in any risk of it actually hitting the Earth. It actually is now, going on its way into a longer orbit. Mm-hmm. But it was close, a tenth of the distance of geostationary communication satellite.
That's right.
I mean,
about about 2,240 miles, 2,240 miles, according to this report, is how close it got. Yes, 28 feet. Was that about
bus sized?
8.5 meters.
So if that hit a city, what could it have done?
Ooh. It wouldn't be insignificant if it hit a city, but the chances of it hitting the city were, beyond remote, let alone the planet. It did not happen. But it did make its closest approach at 7:27 Eastern time tonight. So that was just, about 90 minutes ago. But as Bob said, it's merrily on its way. And but it definitely was a close one. Oh, it's the fourth closest of any asteroid ever recorded that did not actually come into the atmosphere of the Earth and passed us by. So that's a close call. But Steve, as you mentioned, this week's news item is about rubble pile asteroids. In case you didn't know, there are two kinds of asteroids asteroiding around the solar system. You got monolithic asteroids, which is like the single dense chunk of debris. It's solid to its core. And then you have rubble pile asteroids, which are numerous pieces of rock, and they've coalesced under the influence of gravity. And they have low density because there are large cavities between the various chunks that make them up. And each type of asteroid poses a different set of challenge when we're trying to protect the Earth from the particularly large asteroids from hitting the Earth. We're talking about the ones that are about 1 kilometer in size or long in size or larger, and those can have real devastating impacts. But generally speaking, when it comes to these large asteroids that can threaten the Earth, older is more dangerous. So, for example, a large asteroid that has been around for, say, 400 million years is not the same threat as an asteroid that's been asteroiding around for 4 billion years. And why the heck are there are these large planet-damaging asteroids that are still out there that are nearly as old as the solar system itself? And that's a question that definitely has a direct impact on every life on this planet. Which of the two types of asteroids do you guys think will tend to, quote-unquote, live longer? The monoliths or the rubble piles? Which one?
The monoliths.
Monoliths.
You would think the monoliths. It's the rubble piles. That's the news
great
item
science
this
fiction.
week. Yep.
Wow.
A new study published a few days ago in the Proceedings of the National Academy of Sciences. The scientists discovered that rubble pile asteroids are extremely resilient. They are hard to destroy by collision, and that is why they've hung around for almost as long as the solar system has existed. The authors of this research article, Fred Jordan, Nicholas Timms, Tomoki Nakamura, Dennis Fogerhaus, sorry for pronunciation,
I would
and
just do the
7
first
others.
guy's name.
Dennis F.
Yeah, et
Dennis.
al.
From the abstract, such a long survival time for an asteroid is attributed to the shock-absorbent nature of rubble pile material and suggests that rubble piles are hard to destroy once they're created. Our results suggest that rubble piles are probably more abundant in the asteroid belt than previously thought. We studied 3 regolith dust particles recovered by the Hayabusa space probe from the rubble pile asteroid 25143 Itokawa using electron backscatter diffraction, time of flight secondary ion mass spec, atom probe tomography, and argon dating techniques. And the results showed that the particles have been affected by shock pressure. When you combine it with thermal and diffusion models, the results give you the age of these rubble piles at roughly 4.2 billion years ago. And they said that that was a very surprising result when they put it all together. These
Evan, could that be? I'm just trying to understand. So, does that mean that the rubble pile asteroids tend to be older than the monolithic asteroids? That's when you say survive
Yes.
longer. That's what you mean. Couldn't that just mean that over time, monolithic asteroids have a tendency to be shattered into rubble pile asteroids, and therefore, it's unlikely for an asteroid, especially like a smaller asteroid, to survive for billions of years without eventually being pummeled into a rubble pile?
If I follow you correctly, Steve, I think so. I think the answer to your question is yes. But you understand that the rubble pile asteroids were once monolithic.
Yeah, right. That's the key, I think.
Yeah. So even though these things do break up over time, they don't scatter. They don't, fly off in many directions.
Yeah, neutral gravity.
Gravity helps keep them together. And, but for a very, very long time, longer than you would think, they would eventually bump into other things that would send them scattering off, into various directions. But apparently that does not happen nearly as much as scientists once thought. And that these rubble pile asteroids are there's more of them than they thought. And they're out there. And, they are resilient. Very, very resilient. They said very abundant, very resilient. Since they are the shattered bits of monolithic asteroids, they're relatively small and hard to spot from Earth. So there's another key there, is that these things apparently have perhaps a little bit more difficult to detect. I mean, what if we had a rubble pile asteroid this past Saturday hurtling towards us, and we only discovered it with a couple days' notice? There's nothing we can do. Not a darn thing. Yeah. All the tech in the world wouldn't have helped us on that one. It's great. As far as how they discovered this is really great, because they retrieved dust particles back from, I mentioned that Japanese space mission. This was back, I think, in 2010 is when they recovered. They took samples of dust collected it from an asteroid and retrieved it, brought it back to Earth to study. And when they've been using electronic beams at the particle to detect electrons that get scattered back. It tells them if a rock has been shocked by any meteor impact. And this particular set of samples from Itokawa, they determined it was 40% porous. This is giant rubble pile asteroid out there, 40% porous. So it's made of, a lot of it consists of empty space or voids. And if you're going to have these collisions, it just crushes the gaps between the rocks instead of actually breaking apart the rocks themselves. Yeah. So these things are really hard to deal with. What it also means is that if we're going to have more missions like the DART mission, if you guys remember from last year, in which we did crash a probe into an asteroid to change its direction, and that was a rubble pile asteroid as well, and it was successful and it did deflect it. It means that you have to have a lot of time. You have to be able to see these things coming with a lot of time to spare, so that you can prepare and launch the probe with enough time to make that change. There's still not a good solution for the ones that come on, that get discovered or are going to come up on us very, very quickly that we can't plan for these kinds of abatement systems, I guess is what you would call it, or deflection systems. So yeah, something scientists uncovered and reported on from looking at those dust particles that they collected 10, 12 years ago.
Yeah, cool. I mean, it would absolutely be much more difficult if we had a rubble pile heading for the Earth than a monolithic asteroid, because you hit it with stuff and nothing happens. It'd be harder to
use
move.
the gravity
it'd be harder.
tractor method.
Yeah, you can't get the kinetic energy needed. They said perhaps a possible solution would be a nuclear explosion in space, because that would create apparently enough kinetic energy that you could significantly move a large rubble pile asteroid away in a relatively short amount of time. But then you get into a whole discussion about what are the pros and cons of launching nuclear devices into space to deal with the asteroids. But that that may have to be considered. Refer
back to that discussion we just had on the precautionary principle. If we're going to be hit by an asteroid, I'll risk the nuclear explosion in space.
Yeah, I suppose you would, because what do you have to lose at that point?
Exactly. What's the alternative?
Yeah, I think it might be rare for a nuke to help with the rubble pile, though. I mean, I've heard some talks of the pile just kind of like exploding a bit and then recoalescing because of gravity. I think the gravity tractor method might be the best, but you need to identify it within, it could be years or even decades before it's going to happen to have, to really increase your chances of being successful.
But even if it recoalesces, does that really matter if it gets knocked off course?
But the question is, would it get knocked off course, or would all the energy go just to move it apart and have it come back in? It doesn't actually.
And stay completely perfectly on trajectory?
Well, just that a lot of that energy is going to get absorbed by just temporarily moving it away rather than pushing the whole thing.
Yeah,
I don't know a lot about physics or calculus.
And it depends.
But I thought you don't need to make that big of a change when something's that far away.
If it's that far away, that's the point.
That's the key.
It's
dependent on distance.
Right.
If
it comes down
5
to
months away, it might be like, nothing you can do.
Nothing.
Right.
Yeah, nothing will
and that's
happen.
it's all about early detection. That's
hey, look,
key.
just don't look up. That's all I have.
Exactly. Yeah.
All right, Kara, give us an update on traumatic brain injury.
Yeah, so there's an article that was just published in JAMA Neurology just a few days ago as of this recording by researchers from UPenn and the NIH and Johns Hopkins, University of Mississippi Medical Center, titled Head Injury and Long-Term Mortality Risk in Community-Dwelling Adults. So basically what they did is they looked at database research from this really interesting longitudinal study called the, I don't know if it's pronounced ARIC or ARIC study, the Atherosclerosis Risk in Communities study, which is an ongoing study of over 15,000 people that first enrolled between 1987 and 1989. And they're from Minneapolis, Washington County, Maryland, Forsyth County, North Carolina, and Jackson, Mississippi. So yeah, Minnesota, Maryland, North Carolina, and Mississippi. These are individuals that were not in hospitals. These are just people living in the community who were followed longitudinally for years and years and years. And what they did is they said, we want to look at the people who have had injuries, head injuries, traumatic brain injuries specifically, and compare them to the people who have no history of head injury. And over 30 years, they found that people with head injuries, that 18.4% of the total population that they studied, I think they looked at 13,000 people in total, 18.4% of the people that they looked at reported one or more head injuries at some point during the study period. 12.4 of that percent, so 12.4% of 18.4%, was identified as having had a moderate or a severe head injury. When they looked at the death rate across the whole cohort, because remember they were looking at them over a long period of time, and this was the death from all causes, so just death, that's all they were looking at. 64.6% of the cohort who had suffered a head injury died, and 54.6% of those who had not suffered a head injury died. And so they found that when calculating for all sorts of different variables, that the death rate among head injured individuals was 2.1 times the mortality rate among those with no head injury. And when they further looked at those with more severe head injuries, it was even higher. It was 2.87 times the mortality rate than those with no head injury. So basically, the outcome here, as quoted by the lead author from Penn, our data reveals that head injury is associated with increased mortality rates even long term. This is particularly the case for individuals with multiple or severe head injuries. But, of course, it's important to remember that this is not predictive, right? It doesn't explain why the cause of death in individuals with head injuries is higher. It's also, here's another interesting finding from this. When they actually wanted to pull out, because of the people that died, people died from cancer, cardiovascular disease, and neurological disorders, so things like dementia, epilepsy, and stroke. But they found that among the head injury individuals, neurologic specific deaths, unintentional injury or trauma like falling down was more frequent. And for example, when they actually looked at the specific neurologic causes among the head injured part of the cohort, they found that 2/3 of the neurologic deaths were neurodegenerative, so like Alzheimer's and Parkinson's, and that was a much higher percentage among those with head injuries. So the percentage of deaths caused by or associated with Alzheimer's and Parkinson's was 14.2% among the head injury group, and it was only 6.6% among the no head injury group. But again, this doesn't tell us whether people who have a propensity towards Parkinson's and Alzheimer's are more likely to suffer head injuries over the course of their life, or whether people who have suffered head injuries are more likely, for example, to experience these neurodegenerative diseases. This is not a causative study. It's correlative. But it is interesting to show that there's a clearly significant difference and that head injury is associated with a higher risk of death, and specifically a higher risk of death from neurologic causes.
Yeah, I think all of the things are probably true, to be honest.
Yeah, I think it's
they're all
probably a
so
combination of
plausible.
everything.
Yeah, so there is probably something about people who get a head injury that means that they're engaged in behavior that is more likely to put them at risk of head injury.
Right, because it's sports usually. I have
bike
it
riding,
in here somewhere.
motorcycle riding,
It's
skiing,
accidents. Yeah. Unintentional falls, motor vehicle crashes, and sports injuries are very common. Yeah,
absolutely. But also, like, for example, if you get a traumatic brain injury because you were in a car accident, which is a very, very common cause, that tends to cause frontal lobe damage because that's the mechanism of the injury, right? You go backward and forward and you hit your frontal lobe. That can impair judgment. That could basically cause traumatic induced ADHD, essentially, and poor executive function. I had one patient, their life was destroyed by that kind of injury, where they just became like they could not manage their life after they had that kind of injury. So it's very, very common. So you could totally imagine that, with that injury, you're not going to be taking care of yourself as well, and you might be engaged in more risky behaviors.
Yeah, and I mean, look at the extreme end of the spectrum, like CTE, right? Like in the extreme end, it's like multiple concussive injuries causes a persistent and predictable pattern of behavior that often involves like unpredictability and violence. Like it's really interesting how there's a syndrome associated with multiple concussive injuries to the brain.
Yeah, and it's also plausible that the injury itself sets the brain up for not aging well and for degenerative
inflammation, all the
whatever.
things that would happen. Yeah.
Yeah,
and also, again, it could be that those who have a propensity for certain types of neurological disorders may actually be also have a propensity for falls or may have a propensity, so it probably does go both ways, but it is very likely that there's a predictive function there, that the head injuries do set something in motion.
Yeah. Again, I think it's multifaceted. I think all those things are happening. The only real question is to what degree, like what's the percentage? for each of those things. But I think they're probably all involved.
So basically, the study authors are, again, sounding the alarm, like so often we see that, like, even one head injury is dangerous. Like, we should always wear a helmet. It is just not worth the risk not to. Always wear your seatbelt. It is just not worth the risk not to. And when you're playing sports...
Why can't your brain heal itself better?
Here's the
There's
problem.
a lot there.
I'll just add one thing. I mean, we could talk about that a lot, but here's the one thing. The traumatic brain injury itself usually results from what we call diffuse axonal injury. So imagine like the trauma of the brain shakes the brain so hard that you break a lot of the little axons, the connections between the brain cells, and they just never bounce back.
And also, we barely have any immune or like fixers. We've got some astrocytes, we've got some microglia, we've got things in the brain, like cells that are kind of good.
There are stem
at
cells.
helping out.
There are neural stem cells.
But it's not nearly like our somatic cell, the rest of our body. We just that's why it's brain infections are horrific. That's why we have a blood-brain barrier. It's not good when certain things get into the brain because the brain, it's more preventive than it is reactionary.
Mm-hmm. Yeah. No, it's often life-altering. And the best way to treat it is to prevent it. Absolutely.
That's why we have a skull around our brain. We don't have a skull around any other part of our body for a reason.
Yeah. Well, we have rib cage. I mean, doesn't that protect heart and lungs?
It does, but it's not a skull.
Yeah, but the skull's not enough. With the speeds and the forces that we deal with in modern life, the brain...
The skull was great before football and cars and all those things.
Skiing and how about that new, that slapping sport that's out now?
That's ridiculous.
Kara, have you seen any of this?
Yes, I have.
I mean, what the hell? I mean,
just play pickleball, people. Come on.
All right, Jay, it's Who's That Noisy time.
Last week, I played this noisy. So, what do you guys think? What's happening?
Those are porgs. That's a Star Wars reference.
Not a good one, but yeah.
Kara. No, a terrible one.
Well, Howard accordingly, said, my son Lewis wants to guess this week's noisy. He says, a peacock in the forest that's being attacked by a lion.
Oh, no. Poor peacock.
Thanks, guys. Have a good one. Yeah, I mean, I've never heard that noise. I would imagine it'd be a little more gory than the sound that we heard this week. Visto Tutti has an opinion on what this is. He says, it sounds like a squeaky door, so making a better guess, I'm saying it is a squeaky door.
Yeah.
And then he said, thanks, Kara. I was going to say a freaking sea mammal.
Ah, right. It has a distinct sea mammal quality to it.
So we have a peacock being attacked by a lion in the forest and a squeaky door. That's the range that we've established here. Another listener wrote in named Asmund Grostad and said, as a non-dog owner who had a cat as a kid, I feel confident and fully competent to declare this as a bunch of dogs yawning, or perhaps wolves.
Wolfie.
Yes, that is my response to that guess. Wolfie. Michael Blaney wrote in and said, hi, Jay, I'm glad you clarified to Kara that this is not a marine mammal. Apparently, Kara, there's a lot of people that keep hearing marine mammals. Mm-hmm. Because, that would have been my first guess. So I'm going with it's a couple of people carefully letting air out of balloons. And then he gets specific and he says it's letting air out of weather balloons. Now, I didn't read up on this, but I'm pretty sure that weather balloons are filled with helium. Yeah, I think they are filled with helium. I don't think they're not just filled with hot air but I could be wrong. But anyway, it doesn't matter. Letting air out of a weather balloon. I don't know if that would work that way. I don't know. I don't think they have the same kind of makeup as like a latex balloon.
I'm reading either hydrogen or helium.
Okay.
For weather balloons.
All right. Well, we have a winner, and this week's winner is Sydney Goulet. And Sydney wrote, hello and happy Saturday, Jay. I love unexpected animal noises, and this one sounds so familiar that my guess for this week's noisy is that it's a rhino. Thank you for all the work that you do. And yes, this is a baby rhino, as a matter of fact.
And we did play this before.
Yeah, we did. Now that I've heard it a few times, I definitely remember it. But it is adorable, and it is worthy of a second listen. So check this out. I mean, that sounds like an anime character to a weird cartoon to me. Doesn't even sound real that an animal would actually make something so ridiculously cute like that. So Craig Good, actually, I said, did I tell you last week that Craig Good sent this one in? Craig is an old friend of the show. Gave me one of the best experiences of my life. Thank you, Craig.
We should probably clarify that that's non-sexual.
Yeah, that is non-sexual.
No, I don't think you need to clarify that at all.
It's better you don't.
We'll leave them wondering.
All right, I have a new noisy this week. This noisy was sent in by a listener named John G. Okay. I promised you that whenever I used a sonification that I would let you know. So this is a sonification. I don't like playing them because they could be so unbelievably anything. Mm-hmm. But this one happened. My clue for this week is this one happens to be famous.
Okay. That's fair enough.
Okay. So if you think that you know what the hell I just played, or if you heard something cool this week, email me at wtn@theskepticsguide.org. Steve, let me ask you a question. How does it feel to be utterly famous on TikTok?
I don't know. I have no idea.
You're right. You don't have any idea. That's because
maybe one day.
Anybody have any idea?
There's a lot of crazy famous people on TikTok.
Oh yeah, the people renting my house from me
are
famous TikTokers.
No, but we do have over 1,000 people are following us now, which is not bad after doing it for a couple of weeks.
Well, by TikTok standards, it's pretty terrible, but it'll get better.
It'll get better. Oh yeah. I mean, we're having a lot of fun with knocking down, wacky pseudoscience that we're finding on there. And we also came up with an idea, like we took this one video of Steve where he's just kind of listening to the person talk and he's reacting with his face. And Ian and I thought it was funny, so we posted that.
Nice.
Steve's kind of like, like, okay,
Where's this going?
Yeah.
Not where you think it's going.
But we found some awesome content for this week. So definitely check it out after you hear this. It's tiktok.com/skeptics guide. And that should get you to our page. And what else we got going on, Steve?
Well, this is a reminder that there will be a Q&A at 7 p.m. on January 29th at 7 p.m. Eastern with David Gorski, myself, the director and producer of the movie Virulent, The Vaccine War. So you can stream the movie anytime between now and then. I know when this comes out, there'll only be basically a day and a half to do that. You could stream it, and then you could join the Q&A online. Go to Science-Based Medicine. You'll see the post for that near the top, and all the information will be there.
And one more quick note. So we, Steve, Ian, and I started to get together. We're getting together once a week, and we're making content. And part of the content is the TikTok content. And the other part of the content is content that we're making for our patrons. So they get early access to YouTube videos. And right now, the current thing that's happening is I am asking Steve a science question, and Steve gives me some type of snarky answer. No, he gives me an answer. We have a little discussion, about 10, 15 minutes worth of a discussion about something that, is either in the news or something that's interesting or something that's valuable to know about. Like, we discussed the speed of light and got into some interesting topics about the speed of light. So anyway, you could go see these on our YouTube channel. At this point, one will be going up every week on the YouTube channel, and one will be going up every week to the patrons.
That's
so if
the
you
plan
want,
anyway.
If you want to get early access to this content, you could become a patron of the SGU. Go to patreon.com/skeptics guide. And again, we would like to thank our patrons. If you happen to be a patron of the SGU, we really do appreciate your support. It means the world to us because it gives us the bandwidth and the ability to keep going and keep doing what we're doing. Because as you know, it's very difficult to make content like this, and it does take us a lot of time and energy to produce the show. So we appreciate any support that we get. And Kara would like to say something. Go ahead, Kara.
Yes.
That's it. Kara says, Kara agrees with what I said. That's what you get when you
True.
put Kara on the spot.
Affirmative.
You get an affirmative.
All right, guys, let's go to the questions and emails. I have a couple of interesting ones. Might not be able to get to both of them, but we'll start with this one. So actually, we got a bunch of emails responding to the Aptera solar-powered car segment in science or fiction. Mostly negative. There's a couple of positive ones. Don't want to mention names because I thought they were a bit snarky. That's okay. We don't mind that. But I'm going to push back and tell you that you're completely wrong. So I'm not going to mention your names.
Wow,
So
completely
there.
wrong.
Here we go.
Basically, I mean, so a few, 3 or 4 people emailed to basically say that Aptera is a scam, that the car they're claiming to build is vaporware. 2 people used that exact term, vaporware, and that they were shocked, that was the science on science or fiction, that this notion that a company announced that they're going to go into production this year for a solar-powered electric car. So, of course, as I pointed out, I carefully worded that. The item was a company announced that they're going to do that, and that is absolutely true. But, I don't say that if I don't think it's plausible. You know what I mean? It's not a gotcha. Like I don't put as science items that I think, even though they may technically be true, I don't think they're real or plausible, right? I mean, that's something that I've said in the past. But I think that all of these emailers are misinterpreting the history of the company, and they're essentially looking at the company from the outside and jumping to conclusions about what's going on. And if you do a somewhat of a deeper dive, it becomes clear that their assumption, that their interpretation of, again, the superficial facts looked on from the outside, is that the company is a scam, it's a Ponzi scheme. One person said that it's vaporware, is not fair. And so let me go over the history a little bit and to put it into perspective. And this is, I've read now in preparation for this follow-up, a dozen articles on Forbes and The Verge and, reliable, sources. And they're all pretty much telling the same story. It doesn't seem to be anything controversial about the basic facts. So, yeah, Aptera was founded in 2006 with this idea that it was going to produce an electric car, like a super efficient electric car. And it was going to have solar panels on it, but the solar panels were just going to run the AC. And that was it. It wasn't going to recharge the battery or run the car. Remember, 2006, solar panels sucked, right? They were much worse. We were flirting around with 10 to 12%. Now we're at 21, 22% for commercial solar. So completely different ball game. Battery life was much smaller than it is today. And so but it was the same idea. They were going to make a 3-wheeled, super efficient electric vehicle. But also think back to that time, between 2006 and say 2011, in that period of time, all electric vehicles were really a small number. They were considered, futuristic, fringy. They weren't mainstream yet. All electric vehicles had not gone mainstream. Now, there was a program by the Department of Energy to fund startups that were doing certain things, like making all-electric vehicles, among other things, like producing solar panels and making electric batteries. The Tesla, famously was given a huge funding from the Department of Energy, and that saved Tesla in the early years, allowing it to get to the point where it was making money. This is the Advanced Technology Vehicles Manufacturing Loan Program, ATVM. So Aptera, again, it's a struggling startup at this point. It did get a promise of the DOE loan, but it was contingent, right? So 150 million, that was in 2011, but it was contingent on the company raising 80 million from the private market. By this time, The two people who founded the company, Fambro and Anthony, were kicked off by the board. So they were no longer on the board of Aptera. And basically the company was unable to raise the $80 million. They didn't get the DOE loan and they were dead. They were just financially dead in the water. And the company failed. It happens. Startups fail because they don't get the funding that they need. What happened at that point in time is that the company was basically sold off for parts. And a Chinese company, I mean, a lot of people bought different aspects of the company, but a Chinese company bought all of the patents and the IP, right? They bought the IP and they were planning on making a gasoline version of the same car, right? They made a company, Aptera USA, and they were going to make a gasoline version of the Aptera, which is funny because one of the emailers said, oh, yeah, they were going to put out a gasoline car in 17. Actually, that was a different company entirely. But it turns out that this Chinese company, this Chinese automaker, just sat on it and did nothing with it. And they didn't even apply in the U.S. for their trademark or anything, right? They didn't apply the IP or patents or trademark. And so that meant that the IP was fair game. So what happened in 2019, the two guys who started up the company in 2006 restarted the company, right? So now you have the company coming back to life in 2019. And since then, they've been developing what we talked about, a newer version of the car, that's super energy efficient, 3-wheeler, 2-seater. But this time with the solar panels actually recharging the battery, and you could actually drive off of the energy being generated by the solar panel. So what's been happening since 2019? Well, they're making money. They're not making money. They're getting capital. Again, one other new thing that sort of happened since then is online revenue generation. So they went to WeFunder, got $200,000 from WeFunder. They used that as their sort of initial startup. They then got some private funding. So they had like $4 million of Series A funding in 2021. Now they're trying to raise another $50 million. They're well on their way to doing that. And so, you can argue about whether or not they're on their timetable. All right, so if they're behind their initial rosy timetable, that's like every single startup ever. That's not evidence that the company is a scam. But I looked into as much as I can. What's their status? Well, they have a factory. They have an agreement with Red Viking to produce the robots they're going to use for their factory. They're actually using an innovative factory floor design. They're not going to have those overhead, robots with an assembly line. They're actually going to have robots pick up the cars and carry them to the next station where the next thing happens. And they said this is more versatile, flexible, and expandable. It could be easily relocated. So they have a factory. They have a contract with the company that's going to provide the machinery. They have a contract with the company in Italy to make the body. They have a contract with a company to provide the batteries. They have a contract with another country to make the solar panels. It's a totally different story now. It sounds like it's happening. They've already produced pre-production vehicles that they've run through crash testing. So, really, they're on the verge of the next step, which is production, the producing cars that they're actually going to sell to people. The first 200 are going to be the Paradigm version of the car. It's called the Paradigm. It's just the initial 200. And then the pre-production cars they made were their Gamma version. They, based upon the testing, they tweaked it. So now they have their Delta version. That's the version that's going to go into full production. Again, they're saying by the end of this year. I wouldn't be surprised if it's next year. That's the way these things work. Things always fall a little bit behind schedule. But this is not a scam. It's not a Ponzi scheme. It's not vaporware. That's all BS. This is a real company that is, all of the hallmarks are there that they are on a path to actual production. I've read a lot of articles about it from Forbes and other places. None of them are expressing skepticism about this company being a total scam. But there's some, I think, completely plausible, completely reasonable skepticism about like, is this really the best use of a solar panel? Wouldn't you want to put the solar panel like on your garage rather than on the car? That's fair enough. But at the same time, they acknowledge that it's not good for efficiency for the solar power efficiency to put it on the car, but it is good for convenience. So, if you're willing to accept...
no los both.
Yeah, if you're willing to accept 30% less production for that same area of solar panels, you have the convenience of driving around with them, for whatever that's worth. It's not just at your home or at your work. You're taking it with you. So that's an interesting trade-off. I don't know what people are going to think about this. The cars will be configurable for anywhere from a 250-mile range for $23,000 to a 1,000-mile range for closer to $50,000. So basically, you buy whatever size battery you think you need. I think the 1,000 miles is overkill. If you want the cheapy version, you get it with 250-mile range, which is more than most people need. If you want to pad it out a little bit, you just pay more for a bigger battery. So some people were saying, the 1,000-mile range might be good for people who want to go on prolonged trips in remote areas. They want to be able to make the whole trip on one charge, And also you have the added bonus of being able to, recharge it during the day if you get some sunlight.
Remote areas with that little 3-wheel thing?
Well, yeah, that's it.
I won't be going off-road with that.
Not necessarily off-roading, just places where there aren't rechargers.
Yeah.
I also found out that the recharging connection they're using is the Tesla one, which is now the North American standard.
What?
That's right. That's what I read. It's now that they're calling it the North American standard.
But the standard is
recharging
every
connector.
Other car uses the Chase. Tesla. So infuriating.
You get an adapter.
There already was a standard, though. And then he was like, we're going to make ours not use the standard.
And then they outbuilt everybody, and now they're switching over to the Tesla. When we got our car, we just got adapters for every other kind of...
but the thing is, we don't get adapters for Tesla.
Well, get one.
No, but I don't think... I think it's proprietary. It definitely doesn't come with other cars. I mean, maybe soon it will. Like you said, if it's the new standard,
it becomes a standard,
it'll
have to.
That.
Yeah, it'll have to. You can't have an adapter for this now enforced standard. Yeah.
Yeah, but if you think about it, part of Tesla ownership was that you could charge for free at any specific Tesla supercharger station. They're not going to keep those open and free for people if anyone can charge in them.
No. They know what car is attached. When you attach to a Tesla charging station, they automatically know what car you are. They connect to your account. They know who you are.
Right.
And so so that's not going to be an issue.
But they're going to have to I guess not. I guess just you can still not go to the Tesla, or maybe they'll be nice and let people pay to use those.
Yeah,
because that's always really
you have an
annoying
account and you just pay. Yeah.
It's like there was a time when there were charging stations everywhere on the West Coast. Let's say my reality in Los Angeles was there, you would go someplace and there would be 8 charging stations or 4 charging stations. And for a long time, it would be 4 regular ones and 1 Tesla one. And now it's 4 Tesla ones and 1 regular one.
Yeah.
And so you can never find when every other car company is not Tesla.
Mm-hmm. Yeah. So, but whatever the standard, they should move to some standard, whatever it is. It's early enough in the game, in my opinion, that if they just go to a standard, then and go forward, and then give everybody who's already have a different adapter, a different car an adapter, and going forward, everybody uses the same connector. It's like my USB-C connector. Finally have all my devices on one connector.
It only took 23 years.
Oh, God. We've literally been talking about this for decades. It's finally.
This means I still got Science or Fiction wrong last week?
That's what that means. That's what this is all about.
That's my takeaway.
But what I find most interesting is how the emailers had a narrative and they interpreted everything consistent with their narrative, but they had bits of information that were unconnected that they were viewing from the outside. It's like, at first they say they're going to do this, then they say they're going to do that, and then they said they were going to have production in 21, and now it's 23. It's like, yeah, but if you look at the details of the story, it all makes sense. This is what happens with startups, and they just restarted a company, with the same name, with the original guys who weren't there when the company went under last time. and et cetera. And it was actually a Chinese company that had bought the IP that tried to do the gasoline thing. And so you can't count all of that, you know. Anyway, it's interesting. And maybe they'll go bust again. Who knows? There's no guarantee. They're a startup. They're making a weird car. It's untested market. You know what I mean? People might not like it, and they go bust. Oh, here's another wrinkle in the story. When the company went under in around 2011, not only did they part of the reason they didn't get the funding was because the private funding basically dried up at that time. Nobody was funding this kind of technology, and also the Department of Energy stopped funding it as well because they got politically burned by the Solyndra fiasco. You guys remember that? And they're sitting on $17 billion that they're just not giving anybody because they don't want to stick their neck out. Can you imagine that? So they already have the appropriation. They have $17 billion that they could give to companies who are developing electric vehicle technology, and they're just sitting on it. So that's what happened. You know, it was external forces that basically made it impossible for them to get funding at the time. The time was just not ready, you know? And so 2019, it's a different world. Solar panels are more powerful. Batteries are more powerful. Electric cars are now mainstream because of, you know, Tesla and other companies. And so they're giving it another go, and it all seems legit at this point. But yeah, we'll see what happens. All right, everyone, let's go on with science or fiction.
It's time for science or fiction.
Each week I come up with 3 science news items or facts, 2 real and 1 fake. And then I challenge my panel of skeptics to tell me which one is the fake. We have a theme this week. The theme is energy efficient homes. These are all items that refer to your energy use in your home. So a lot of articles about this going around, a lot of interest in this recently, and so I thought we would test your knowledge about how to make your homes energy efficient. You guys ready? Okay, here we go. Item number 1. Typical manual dishwashing of just 2 sets of dishes costs more energy and water than running a full load of dishes in a modern dishwasher. Item number 2. Homes with incandescent bulbs use 15% of their electricity for lighting, which decreases to 1.5% with all LED bulbs. And item number 3. Regardless of HVAC type, it is more energy efficient to keep your home's thermostat at a constant seasonal temperature than to adjust it more frequently. Evan, you made a noise.
That was you.
There's no proof that my sound.
Evan, go first. You were due anyway.
Shame on me. Yeah, I was. Here we go. Typical manual dishwashing. Just 2 sets of dishes cost more energy and water than running a full load of dishes in a modern dishwasher. Manual dishwasher. So by hand, you mean manual. Hand. And when you say 2 sets of dishes,
so 2 people ate dinner.
Like
that's it. Whatever 2 people would use when they were, you know, a plate, maybe a bowl, a glass, knife, and a fork.
So yeah, look, as I wash dishes here, and there is an efficient way to doing it manually. You know, you just don't let the water run. You know, you get some water going, you soap things up, not while it's running, then only when it's ready for rinse, you turn the water kind of back on, rinse things off quickly, and go. So, but you said here typical, and I'm not sure that that's considered typical.
It's not. It's
atypical.
Weird.
Yeah, well, you know, the modern dishwashers and the modern washing machines and stuff, they use less material, less water, frankly, to get the results. So I wouldn't be surprised if that's true. Homes with incandescent bulbs use 15% of their electricity for lighting,
on average, obviously,
which decreased to and it decreases by what do you call that? A order of magnitude with all LED bulbs goes down from 15% to 1.5%. I thought it was even more efficient than that. You know, these LED bulbs, and I have them all over my house. I was reading that these things are going to last, you know, maybe longer than I'll live in the house in some cases. So, boy, that it could be even more efficient than that. Then the last one about the HVAC type. more energy efficient to keep your home's thermostat at a constant seasonal temperature than to adjust it more frequently. Now, I've heard this before. But I don't know if this is like a common misconception. But I have heard that before. To try not to vary it too much. Given each season, winter you keep it kind of moderately warm so it doesn't freeze, and in the summer, if you're using air conditioning, don't get it too cold. Try to keep it. I guess the thermostat one, maybe, because it's always changing. Don't they have these programmable ones now? And isn't that it does change it, and therefore it's supposed to be more efficient? Okay, I'll say the HVAC one with the thermostat. I'll say that one's the fiction.
Okay, Jay.
Yeah, I think that modern dishwashers are so incredibly efficient that they are much more cost effective than hand washing. Most people don't do what you do, Ev. They leave the water on, so a ton of hot water is going down the sink. Yeah, so I definitely think that one is science. The homes with incandescent bulbs versus the LED bulbs. Yeah, I mean, there's a massive difference between power consumption between those two types of bulbs. I saw a demonstration where they used a hand crank, and you use the hand crank to power a old school incandescent bulb, and then you use a hand crank to power an LED, and it was like night and day how fast you had to turn that thing in order to get the incandescent bulb as bright as the LED. So I think that's science as well. And I am a firm believer that you do need to vary your temperature, especially if you have a smart thermostat. You can program the damn thing to make those adjustments. Like, it knows when you're home, it knows when you're away and all that stuff, and it can make a lot of adjustments throughout the day.
It's like Santa Claus.
So I agree with Evan.
Okay, Bob.
I enjoy dishwashing. My hands in the really crazy hot water. I like it.
It's the weirdest thing you've ever said, Bob.
It's just,
not even close.
It's just
second weirdest.
No, not even close. I like it, so I don't care if it's cheaper. I'll throw in. I'll do dishes that I could just throw into the dishwasher. I'll just do them anyway. It seems to me though that those dishwashers run for a while. I would think that you'd be using more water than just two dishes. 2 plates, 2 glasses, utensils, and maybe another bowl. You could do that pretty damn fast.
By the way, it says 2 sets of dishes. I don't think that means 2 plates.
Yeah, 2 plates, 2 glasses.
That's what Steve said. Service for 2.
Service for 2.
Okay.
So it's not absolutely cut and dried there for me, but that's probably science. The incandescent bulbs, yeah, that makes sense. I mean, Jesus, that's looks good to me.
Right, so what's left?
The HVAC one, yeah, that's the one that just doesn't seem right. I mean, because you say it in there where you say that more frequently, that's very broad. More frequently is changing it twice a year.
Yeah, more frequently than seasonally. Yeah.
Yeah, so it's so I think that just doesn't sound right. I'll go with the guys. Say that's fiction.
Okay, and Kara.
Yeah, I'm gonna go with the guys. Spoiler alert. I think that you just let the water run the whole time when you do manual dishwashers or dishwashing. And I guess it kind of depends, but like most dishwashers now are like have that HE. Is that what it's called? Like the high efficiency?
High efficiency.
Yeah. And so
high.
Maybe an old school dishwasher wouldn't, but I think a more modern one would. And I get why you're saying of just 2. So even if the dishwasher wasn't full, but it's probably even better if the dishwasher is like filled to the brim. I think the one that was tripping me up was the incandescent versus LED, only because like my math skills are not good, and I don't know, a whole 15% of your house's electricity cost just in lighting, but maybe, yeah. And now only 1.5% in LED. That's the thing. Like I think they're like 90% more, but does that translate to an order of magnitude difference in the percent? It has too much math in this one. And then, yeah, I do agree that, there's a reason that modern thermostats are smart thermostats. Like you program your night zone versus your day zone. I'm home, I'm away. I think all of that is to achieve more energy efficiency. And if you just had it set to one thing and never changed it, why would we have these like ultra programmable with like little green leaves next to them? I'm a sucker. I've been marketed to. But for that reason, I'm gonna go with the guys.
Okay.
I'd love the green leaf.
Yeah. Steve's gonna be like, "You're wrong."
Such a pleasant visual experience.
All right, so we'll take these in order. Typical manual dishwashing of just 2 sets of dishes costs more energy and water than running a full load of dishes in a modern dishwasher. You guys all think that one is science, and that one is science. That is science.
Yay.
So this is pretty cool, actually. So typical manual dishwashing is with the water running, and it's typical because that's how most people do it. If you are washing the dishes with the water running, like Bob likes to do, it's massively inefficient.
Which, by the way, that's how most people in the U.S. do it.
Well, I
But
should say that. That's fine.
Yeah, whenever I've spent time in the U.K., everyone has this like plastic basin in their sink.
Yeah, that's the best.
And
way
I
to
think
do
it's
it.
because they hand wash it more efficiently there.
So actually,
Absolutely.
washing dishes with the water running is the least efficient way to do dishes, and washing it with a basin is the most efficient way of doing it.
And then the dishwasher's
In the middle.
Wow.
Yeah, but the dishwashers are so efficient because one of the reasons is that they have sensors that can tell when the water's clear. So
Oh, cool.
smart.
they just
Stops immediately.
They stop it as soon as the water runs clear, so it's done. They don't have to waste. They're not over cleaning the dishes.
It was a light load today.
Yeah. And also, the jets are very efficient. The other thing is you don't have to pre-rinse your dishes. Don't pre-rinse. If you pre-rinse, you throw away most of the gain from using a dishwasher.
The problem is...
Yeah, that's a bad
Just
It
habit.
is a bad habit.
Scrape, but don't rinse.
Oh, scrape. Okay, I was going to say the problem is,
Yeah,
I think for a lot of
wipe
people
down.
listening, myself included right now, they're like, but I'm not rich and I don't have a brand new dishwasher. I rent and I have a piece of crap dishwasher in the apartment that I rent and it's not good.
It's
and if
not
I just
good.
wash things without rinsing, they don't come out clean.
Yeah, so this only applies to modern dishwashers. And you're right. The number one thing you could do for your energy efficiency at home is update your appliances. Because the modern appliances are so much more efficient than older ones that if you have a 10-year-old refrigerator, get rid of it. Just get a new one. Yeah. They pay for
Spend
themselves.
thousands of dollars and you'll save hundreds.
No, it's the other way around, Bob. They do pay for themselves with increased efficiency. It obviously depends on exactly what the upgrade is. But if you have like 10-plus-year-old refrigerator, you will save enough money to pay for it. You will. I mean, not if you get a Sub-Zero $20,000 refrigerator, but if you get a $3,000-$4,000, modern refrigerator over 10 years, it will pay itself. For itself in
Remember
energy
when,
savings.
Steve, remember when we calculated Mom's extra refrigerator in her garage? We're like, Ma, we're shutting this thing down.
Yeah.
You're
She
not
had 3
leaving
of
this
them.
running.
3 ancient refrigerators in the garage.
Oh, God.
Like, that's
All
we
churning
shut
away.
them down.
Holy moly.
Same thing with the dishwasher, same thing with your heater. The modern stuff saves a lot of energy and money. So, yeah, and if you have a modern dishwasher, don't rinse. Just scrape into the garbage, put it straight into the dishwasher, and you don't have to feel guilty about running a load that isn't full because it's still better than doing it by hand. And if you do have to do it by hand, use the tub method, not the running warm water method.
Right. That makes sense.
Or just
Total
enjoy the process, enjoy the warm. Or
Stop it, Bob.
And it's, who cares about an extra $5?
It's also just the
Yeah,
environment.
but then you get dishpan
It
hand.
adds up,
you get
times a million families. You know what I mean?
And by the
And
way,
it hurt-
this whole
cracks
this
your
whole conversation
skin.
is not about how much money you save. It's about how much water and energy you're wasting.
Yeah, heating that water
there's plenty more where
takes
that
a
came
lot
from.
of energy. All right.
It does.
And also, we don't have just endless water. We need to stop thinking that
Sure,
way.
I do. Turn on the faucet. There it is. Sorry. Triggering Kara right now.
All right, let's go on to number 2. Homes with incandescent bulbs use 15% of their electricity for lighting. Again, this is on average in the U.S., which decreases to 1.5% with all LED bulbs. You guys all think that one is science, and that one is science. That's also science.
Yeah.
Yeah, I knew this was easy this week. I just wanted to talk about this topic, but and bust some myths. So again, I mean, buying LED bulbs is a no-brainer. It is a no-brainer.
gosh.
Even if you think the upfront cost is a little higher. It'd be like $4 versus $1 for the bulb, but the bulbs last 50 times as long, and they use much less energy. Like you get paid back in months. And then you're saving money for 20 years on those bulbs. Come on, buy the LED bulbs. It dramatically, that's 50, basically 10 to 12, 13, 14% of your electricity use goes away. I mean, think about that.
Why the hell wouldn't you? It's crazy.
You remember when we were kids?
Don't do it.
We were kids, our dads would always say something like, turn off the light, you're wasting electricity. It's just no longer the case. That doesn't mean that we should be nonchalant about keeping lights on that are not
I
necessary.
still turn off lights. Yeah, I'm still
turn them
light
off.
conscious. Yeah.
But it's good.
Drilled into me.
It's good to know that it's almost a round off error on your energy usage. Just 1% to 2% or so. Again, these are all average figures, but
So what does that cost per photon, do you think?
Cost per photon.
Oh my God.
Can you imagine?
incandescent bulbs translate only 5% of the energy they consume into light, whereas LED bulbs is like 80 to 90%.
So you don't know that you're saying.
No, I don't. The photon didn't buzz it. Okay, which means that item number 3, regardless of HVAC type, it is more energy efficient to keep your home's thermostat at a constant seasonal temperature than to adjust it more frequently, is the fiction. But Evan, you are correct. This is a common myth, a common misconception. A lot of people think that, it takes more energy to heat up the home than just to keep it at a constant temperature. But that's bullshit. It violates the laws of thermodynamics. It is it's not that different, right? Like heating up the home versus just maintaining it at a constant temperature is not that much more energy. What it does do, the greater the difference between inside your house and outside your house, the more energy it takes to maintain that difference. The greater
it's like people
the loss
forget that
of energy.
That it's a thermostat, not just a full blast heater or full blast cooler. Like the whole point of a thermostat is that you set it and then it constantly changes to keep it in range.
Yeah.
That's no different than you changing it to keep it in range.
Yeah, it just goes on and off.
Exactly. It's still using energy as if somebody got up there and flipped it on or flipped it off. So it's silly that that's a misconception.
Well, the idea is like, should you let your house cool down to 60 degrees overnight and then you have to heat it back up in the morning? Yes. Because you would be wasting a lot more energy overnight that you maybe don't need. Or if you're out for the day, and you're right, this is why the smart thermostats function this way. That was the big giveaway. Smart thermostats will adjust your temperature based on the time of day, based on whether you're there or not, whether you're under the covers or not, or whatever. You can keep it a little bit cooler when you're in bed, a little bit cooler when you're away for the day, and you keep a little bit cooler in the winter, warmer in the summer, so you're not using too much electricity there as well. I had to say, regardless of HVAC type, because there's one exception to this rule, and that is the geothermal heating systems.
Those are amazing.
You should keep them at a steady temperature because because of the way they work.
They're slow.
They work more efficiently they're very slow. That's right. So if you just keep them at one temperature, but they're so efficient you don't have to worry about it, right?
Plus, you don't want to drain all the geothermal energy in the earth. I mean, run out.
Yeah, that's right. 2 or 3 billion years, and we might drop a fraction of a degree. Absolutely. Yeah. So it's good to some basic knowledge about some home energy efficiency. And
Definitely.
The bottom line is, don't run the water when you don't have to, and update your stuff. Buy LED bulbs, update your appliances, and that's the biggest thing you could do.
Get some better toilets in your house, too.
I promise I will do research trying to determine the cost per photon saved for LED.
Thank you.
For your own curiosity.
Your own edification. All right, Evan.
Myself, I will do this.
Evan, give us a quote.
Is a photon a wave or a particle?
Yes.
Stop.
Thank you very much. Thank you. I was hoping for that would be the answer. Here's the quote. I see science in general as a form of arrogance control, in the sense that it's one of the most organized methods we have of forcing us to put our beliefs to the test and forcing us to face dissonance if the test does not confirm what we believe. Carol Tavris.
Yeah, that's a good quote. Yeah, that's the
quote.
Science. You have to be humble before science, basically. Be humble before the facts.
Right.
Don't double down on your own error. Just whatever the facts say, that's what you got to go with.
Go against human nature.
Okay, well, thank you all for joining me this week.
Thanks, Steve.
It's nice to be joined to you.
Good. And so we'll see some of you on our Friday live stream, to remind you on every Friday at 5:00 Eastern time, or most Fridays. I didn't say every Friday, most Fridays. We do a live stream, and we sometimes have guests, and we just have some interesting, fun conversation. We usually go...
It is fun.
Yeah, much more off-script than we do during these shows. So you get to see sort of a different side of our conversations there. And we have a lot of fun. There's quizzes, there's laughing, there's crying. It's awesome.
Bob animates puppets and other things going on. Watch Bob.
Bob gives you a disturbing look behind the curtain in his house. It's fun. Hey, Jay, where do they go to view the live stream?
They go to the internet.
Can you be more specific?
You could go to the SGU YouTube page, but we stream it on Twitch and Facebook as well. But if you go to the YouTube page, it's the easiest, I think, to find.
All right. Sounds good. All right. Well, thanks again, everyone. And until next week, this is your Skeptic's Guide to the Universe. Skeptic's Guide to the Universe is produced by SGU Productions, dedicated to promoting science and critical thinking. For more information, visit us at theskepticsguide.org. Send your questions to info@theskepticsguide.org. And if you would like to support the show and all the work that we do, go to patreon.com/skepticsguide and consider becoming a patron and becoming part of the SGU community. Our listeners and supporters are what make SGU possible.